good. Just so I don't have to break through the noise later on. And it's about that time. Hopefully I'm coming through well on the owl. I would like to introduce Vincent Ledvina. He did his bachelor's at University of North Dakota and is now at UAF in Fairbanks, Alaska, working with Dr. Don Hampton. I believe you also have done some work and are still doing work with Aerospace Corporation, with Christine Gabriels and Margaret Chen. And you were also an Aurora chaser, as people know, and have plenty of evidence of that. Yeah, I don't think I have anything else here, so everyone welcome.
I'm happy to be here. I got a tour of the labs this morning, did lunch, and it was really good. So today we're going to learn about citizen science. Thank you all for coming. And the title of my talk is Agile Collaboration Citizen Science as a Transdisciplinary Approach to Heliophysics. And what we're going to be learning about today is, first of all, what is citizen science? Second of all, what is something called scientific agility? And third of all, how you can apply citizen science to your research. Just a little bit of background. Oh, sorry. Before we go into that, here's the outline for my talk. Pretty standard. It's very non-intensive. It's supposed to be a fun sort of informal talk about citizen science. Just going to go through why citizen science is important, then define it along with some other key terms, and then get into the fun stuff, which is all the recent discoveries that have happened because of citizen science and aurora chasing. And then finally concluding with how you can use citizen science and trying to dispel some of the misconceptions about data quality in citizen science, as well as sort of how to approach the whole relationship building with the public. So, oh, and of course show and tell as well. That's the favorite thing, right? Okay, so a little bit about me. I grew up in Minnesota along with Joel. I just learned about that today. We're all from kind of like the same area, which is pretty cool. I'm from Maplewood, and that's great because I got exposed to the cold early. So moving to Fairbanks wasn't as bad, and it's excruciatingly hot here now. Almost 100-degree temperature difference from yesterday. So I really like aurora chasing, really passionate about auroras, and I've been interested in this since around 16, 17 years old. That's kind of when I first got into photography. I moved to Fairbanks because of the aurora. I took a gap year and decided, whether or not I would like it up there. I drove all the way from Minnesota, did that journey twice. It's about 7 days. And, I fell in love with the aurora, especially after a sounding rocket campaign. You can't go wrong with that. And that's the recent NASA dissipation rocket launch that I photographed. So I was just out in the middle of the field and, was waiting for the rocket launch. They actually live streamed the count. So you can listen to that on your phone. And, it's choppy in and out because the service is so bad, but I was able to get that picture. And I'm really interested in how the public can become involved with space weather research, with heliophysics research, and just in general want students as well as faculty and senior scientists to understand the different benefits that citizen science has and can have for them. So, like I was saying, now is a great time for citizen science, because there's a lot of macro trends, as I like to call them, in heliophysics, which are emerging and which citizen science could help with. The first is that there's a higher volume of data. So, back in the day, for example, the 70s, 80s, you could publish essentially a 3-page thesis and discover something groundbreaking about the magnetosphere or about the ionosphere. Now it's sort of like looking for a needle in a haystack, and that haystack is 30 terabytes or 50 terabytes of data. And you can do that as a PhD student, or you could create a citizen science project and have thousands of volunteers do it for you and potentially do it faster. So that's sort of the advantage of citizen science with big data, is that you can churn through these observations or these measurements, whatever you have, more quickly, and also produce something educational for people along the way. There's also opportunities to integrate citizen science into what's called the R2O2R, research to operations to research pipeline in space weather. And what that means is research informing operational forecasters, like at NOAA Space Weather Prediction Center, and then those people inform the researchers, what changes do you need to make so you can basically improve the models and improve the data that we can get, and then improve our own forecasts. And there's citizen science projects like EasyMeg, Aurora Source, I'll be going into those later, where there are citizen scientists in the field, especially in areas where we don't have observations, recording potentially useful data that could be sort of put into this process and added as a, maybe secondary data stream to better inform the models and forecasts. So the bottom line is that citizen science is a tool to gather and process data and interface with the general public. And not only is it beneficial for scientists, but it's also beneficial for the general public. So citizen science is just one sort of piece of the puzzle of making sure that we are educating people. Right now, we're in solar maximum. That's the plot of the I think it's sunspot number over time. And as you can see, we're actually outperforming the current cycle 25 estimate by quite a large margin. And because we're in solar max, there's a lot more space weather happening, and that space weather is making it into the news a lot more. So you have people who are not usually interested in space weather or space physics being first exposed to these concepts through usually clickbait articles that are not factual. So citizen science, along with social media posts by scientists, on Twitter or Instagram, informational posts. There's people who run blogs, there's people who go on TV, radio. Citizen science is sort of a more formal way to educate people, in which you can do that through a project, and that you can set up so that the information are very direct and also accurate. So we really need this right now, and it's just another driving force of citizen science. And what is citizen science? This is one of my favorite definitions. It's organized research in which members of the public engage in the processes of scientific investigations by asking questions, collecting data, and or interpreting results. And really what it boils down to is the public doing science, the public helping researchers, and those efforts leading to science results. And I've included a bunch of pictures here. You can see that citizen science takes a lot of different forms and looks very different across the board. You have people interacting with citizen science projects on laptops through web interfaces. You have people out in the field like aurora chasers, capturing data from the environment. You have lots of people working together. Citizen science is very collaborative. So the scientists and the citizen scientist students from all different ages working together, which is great. And you also have collaborations. This is one from the National Park Service. You have government, research institutions and the general public, all collaborating together for a common goal of scientific progress. And here are just 10 principles. So I'm just going to briefly go over these, but obviously we want science results. So the first 2 points there, citizen science, generates new knowledge or understanding, and also the genuine scientific outcome. Point number 3 there is that both parties benefit, both the citizen scientists and the scientists benefit from taking part. And that's really important. Something I'll touch on later is this concept of reciprocity. So if you're designing a project for the public, not only are you getting something from the public to advance your own research, but you have to be giving something back to them, whether it's in the form of education, payment, publishing, or something like that, exposure if you're a photographer. Citizen scientists receive feedback from the project. They participate in multiple stages of the research process. They're becoming involved at every step. That's really important. There were actually a few opportunities where I was contacted by scientists, and I gave them all my data, all this aurora data, and they said, okay, great, and I never heard back from them again. And then they go out and publish a paper, and I'm not included on there. And that really sucks. So being informed of everything that's going on, all stages of the research process, like, hey, by the way, we're still working on this. Thanks a lot for your data. That's really important. Citizen science project data, metadata are made publicly available. There's a huge push for that, especially in the US here. We're in the year of open science as defined by the White House. So all data moving forward and results are going to need to be made public by some degree. But not only those data and results, but also the methodologies should be made open source as well. And that's in the spirit of citizen science. So again, citizen scientists are knowledge, I already mentioned that. Projects and programs are evaluated and iterated. So projects with funding from NSF and NASA have to go through evaluation processes in which there's an external evaluator that comes in and basically assesses whether or not the citizen science project is upholding all these different values and really working towards the science goals that they outlined when they were forming. And then finally, the last principle is that there's legal and ethical issues, there's issues around sensitivity, around data ownership, and all that has to be handled when you're working with the public. So there's this concept of scientific agility. I think this is a really nice framework to sort of center this talk on. Is we all know agility from the sports perspective. It's like being quick on your feet being really, quick to round corners, being able to pivot really quickly, stuff like that, right? You're really nimble. Well, that same analogy, or an analogy in science is being able to quickly pivot from one task to the next. Having a lean team, who are able to respond to challenges and adversity. That's extremely important when you're building a citizen science project. There's a lot of beta testing that goes on. There's a lot of issues that you end up running into when you're first starting out. So having an agile team is very important so you can keep the progress going. But also individuals, just all individuals in general, all humans have agility. We all have an ability to recognize patterns in a continuum. Humans are very, very good at that, better than computers. We can all identify differences and we can all classify things. And citizen science projects exploit that natural ability of humans, that natural agility. And heliophysics, there's a lot of citizen science projects and citizen science efforts going on, but I want to highlight Aurora Chaser since I'm an Aurora Chaser myself and all the different accomplishments that we've made in collaboration with scientists. So there's really three main principles to Aurora Chasers as a group of citizen scientists. First, we create scientifically valuable data, and we do this because we know that our data could be useful to scientists. 20 years ago, that wasn't the case, and I'll go over some of the recent discoveries and how that's sort of creating this positive feedback loop of, Aurora Chasers go out, they're capturing photos, but they know that those photos aren't just gonna necessarily go up on a wall frame. They can actually be used for science. And the data quality of citizen science data in general depends on the project's design. Not only the project's design, but also the interactions you have with whoever you're collaborating with in the general public. So if you invest more time in forming those relationships and clearly defining goals, you're able to get better data as a result. Aurora Chasers also have both contributory and experiential expertise. This is not only true for Aurora Chasers, but all citizen scientists and the general public. And there's two different expertises. There's, depending on what sort of paper you're reading, these are the two main ones. But you have contributory expertise, which is the capability of contributing to what is known about a topic. And in the Aurora Chasing scheme, that means that Aurora Chasers are experts in astrophotography, other technical fields. We may not have this the sort of science expertise that a PhD level space physicist would have, but we have a lot of expertise when it comes to image processing, how images are taken in photography, and that can all contribute to a citizen science project or scientific collaboration. Experiential expertise is developed directly through personal experience, and that's pretty obvious, right? Aurora Chasers are in the field more than Aurora scientists. And it's funny because Christina Lynch, who actually was, I think, a professor here at one point, she's now at Dartmouth, but she went on a sabbatical in Alaska, and we went out Aurora chasing many times up at Poker. And I remember there was one substorm, if you don't know what a substorm is, it's when the Aurora kind of just goes nuts, and it's really, really pretty. But it's one of the most dynamic times of Aurora. It's really scientifically interesting and people study them. And we were out there looking at a substorm, and I remember this because I was standing right next to her. She looks up and she says, "Oh, we really don't know anything about this, do we?" And I just thought that was super cool because, obviously we know a little bit about the Aurora, right? But there's so much that we still have to uncover. And I think by using people's experience and leveraging that, we can gain new insights. And that's exactly what Aurora Chasers do. They tell scientists, "Hey, I've been noticing this weird thing." The scientists don't know because all they do is look at the data. And the data might not show it, but when you're actually out in the field, you know the patterns of the Aurora, the behavior of the Aurora, and you notice when something is not how it should be, for example. So really important when you're doing Aurora science, consult the Aurora Chasers and see what they think about it. But in general in science, it's good to have a variety of perspectives when you're approaching an issue, when you're trying to tackle something, because you might see it one way, but somebody else who's a mechanic or an electrical engineer might have been brought up a different way of teaching or schooling or whatever, and might approach problems in a completely different way that might help you solve yours. So it's important to include a variety of backgrounds and perspectives, and that whole idea is called transdisciplinary science. Finally, citizen scientists and Aurora Chasers promote participation from the general public and sort of act as a bridge between the scientists and just sort of the everyday person. So there's this positive feedback loop that's formed in projects like Aurorasaurus, where you have Aurora Chasers capturing scientifically valuable images of maybe interesting auroral phenomena. Those photos are then shared to citizen science projects like Aurora Source and also just on social media like Facebook, Instagram. And then scientists directly interact with the photographers, the discussion takes place, new science questions emerge, science questions are answered, and then the whole thing starts over again. So it's like this positive feedback loop in which the citizen scientists are sort of a bridge. And here are some recent discoveries from Aurora Chasers. And we're gonna be going into all these just in a little bit, but does anybody know what this one is? Steve, does anybody know what these are?
Rural beads.
No, not auroral beads. Does anybody know what this one is? These are ones that are kind of obscure, so it's okay if you don't know what they are. Okay, nobody knows. Does anybody know what these are? Okay, well, yeah, actually, so you're on the right track. All right, so Steve is probably the most famous discovery. We're gonna listen to a quick video about that.
Out observing the aurora, and they started noticing something that was overhead as well when they were seeing the aurora far to the northern regions. It was unlike most aurora. Talked to the scientists, we didn't know what it was, and together they said, we'll keep taking observations and we'll call it Steve in the meantime. Steve is mostly a very narrow purple arc, and sometimes it has these little green features that go along with it as well that are kind of like waving fingers or a picket fence. That means that there's plasma physics happening up there to cause that light and to make these little discrete features that we don't understand yet. We now have some satellite observations from the ESA satellite called Swarm that show that Steve optically is associated with a very strong flow in the particles in the ionosphere, the upper level of our atmosphere. Steve is important for a number of reasons. It's really exciting that people armed with cameras all over the globe can capture something that we didn't fully understand and shed new light on that. It's also really exciting that this happens further to the south where there are more people. So it might be a kind of aurora that more people can see than the usual kind. We're now able to look up at the sky and see things about the aurora and this sub-auroral region that we never understood before. And then we can correlate that with our traditional observations and lead to greater understanding.
All right, so that was Liz McDonald. She was the first author on the paper that described Steve, and also that conjunction that she mentioned. Aurora photographers had an image of Steve, and then they found a swarm passing right above that identified a really hot flow of plasma, which is what they think Steve is caused by. So it's sort of the most famous citizen science discovery, and it seems like it's been forever ago, but actually it was just in 2018, if you can believe that. Obviously Steve's been around for a lot longer. Here's the first image of Steve that we know about from Carl Stormer back in 1911. That was in Norway, I believe. And he called it a feeble homogeneous arc of great altitude, which I just think is so funny. It just sounds like something from 1911, but so yeah, basically the story is Alberta aurora chasers started noticing this weird streak in the night sky that was not to the north. So aurora in the northern hemisphere, obviously, to the north, northern lights. Well, they started noticing this sort of mauve, pinky, whitish band that was flowing from the eastern horizon to the western horizon. And it was specifically after what's called a substorm recovery phase. So the main aurora would happen, it would dance to the north and do its thing, then you have pulsating aurora. That's usually when people start to go home, they sort of pack up their gear, they're like, okay, show's over. But then all of a sudden they start seeing the streak, and it was known that this streak was there, and scientists thought it was a proton aurora because they didn't think that you could actually see it with your own eyes. Obviously, it had been photographed before 2018, but when aurora chasers actually started noticing this and posting about it more, they went to scientists and said, hey, by the way, we're seeing this weird streak in the sky. They'd show them the camera images. The scientists said, oh, that's just a proton aurora. Yeah, we know all about that. That was discovered back in whatever, the 60s or 70s. And then the citizen scientists said, no, we can actually see this with our own eyes. And the scientists said, oh, wait, that's much stronger than a proton aurora, and it's maybe not the same thing. Then they started seeing these picket fences. And this is actually a movie that my friend Justin shot. And this is a picket fence, but it's a weird picket fence. It's kind of a stripe. But here's more imagery showing this sort of periodic green emission, and that does not happen with proton aurora. That's actually precipitation. So Steve is not a typical aurora because it's not precipitation of particles along magnetic field lines, which is sort of the canonical definition of aurora. And instead what it is basically just broadband emission caused by superheated plasma flowing really, really fast. So it's like if you heated up a metal and it started glowing, right? It's sort of the same idea. And this picket fence feature is really interesting because it's not the same mechanism of Steve, and the emission is also a very, very pure green line. So it's really weird how it's uniform, and that is a big question is whether or not the picket fence actually is precipitation. Some people think it's caused by parallel electric fields accelerating particles, and not like parallel electric fields in the geosphere, but locally in the ionosphere. But anyways, it's just one story of aurora chasers teaching scientists something that they thought they knew, but really, you know, it was something more than that. And it's really inspiring and sort of led to all these other discoveries, which I like to call Steve and Friends. So, so, you know, there's a discussion as to, you know, where do we stop? And when do we call all the auroras that we have good enough? But it seems like every single day there's a new aurora that, you know, is discovered. And this one is kind of cool. It was discovered, and when I say discovered, it's more like just shed new light upon. Obviously, these auroras have been here forever, as long as Earth has had auroras. But it's not until recently, and with the evolving camera technology, popularity of aurora chasing, and also spotlight on the fact that there are these rare auroral phenomena that need to be discovered and sort of reanalyzed, that we've seen all these different names pop up. So this one's called Red Aurora with Green Diffuse Arc, or ROCDA. Doesn't flow as well as Steve. It doesn't have that, you know, popularity aspect maybe. It was found by aurora chasers in Finland, actually. And
Maybe it sounds better in Finnish.
yeah, maybe it's better in Finnish. I'm not even gonna try. I don't know what that would sound like, but and this one is actually potentially due to proton aurora emission, but I don't think it's visual. I've actually never seen a ROCDA. I've seen Steve's, I photographed Steve's. In fact, the first image of Steve that I pointed to was my own. But these ROCDAs are usually subvisual and proton aurora. And then you also have stable auroral red arcs or SAR arcs. These are very well known in the scientific community, have been observed for decades, but the transition from SAR arc to Steve has not been known until recently. So there's a really good paper by Martinez et al. 2021 that you should check out that uses citizen science imagery, as well as some scientific grade all sky cameras to show the evolution of a SAR arc to a Steve. So a SAR arc is also a hot flow channel, but as it evolves, potentially it shrinks, and then that flow increases in speed and then changes color into a Steve. So who knows? That's kind of the main theme around all this is these questions are still brewing. We don't really have solid answers yet, but we're discovering new things about these auroral phenomena because of citizen scientists. And aurora chasers are really pioneering the study of Steve and his friends. Another friend of Steve, or I guess not really a friend of Steve, but occurs roughly at the same time during the substorm recovery period, are these auroral dunes discovered in 2020, again in Finland. There's a lot of aurora in the US, but there's also a lot of aurora in Europe too. People forget about that. There's whole citizen science communities all over the place. But it's important that, you know, we acknowledge that there's both Northern Hemisphere and Southern Hemisphere communities. So this dune shelf, if you can see it here, is this sort of diffuse aurora that usually occurs after substorms. You can get these things called giant undulations as well, which look like big U-shaped structures. But this dune shelf is modified by gravity waves. And I'm not a gravity wave person, but I found this cool diagram online that sort of shows in what altitude range you'd expect this inversion layer to form and these gravity waves to start propagating through. And it modifies the emission of the aurora to look like sand dunes, which is why it's called auroral dunes. So this was discovered in 2020 by citizen scientists. And you can weekly see this to the eye. I've never seen dunes, but they pop up all the time in southern Canada. And I was living in North Dakota for a while. I just never got to see them, but saw a lot of Steves. This is my favorite one. I think this is the most exciting one. And these look like kind of like auroral beads. That's what my thesis is on auroral beads. So not citizen science, Steve stuff, but using citizen science to study auroral beads. Anyways, they kind of look like beads, but really they appear very similar to what are called the feet or the streaks below the picket fence in Steve. And this kind of throws everything on its head because we thought these, steves and these picket fences only occurred after substorms during quiet times of aurora, but these fragments can occur literally, it seems, during any time of the aurora, especially during substorms, where you have these really fast flowing auroral arcs, these streamers. So these FAEs, as they're called, were first discovered in Svalbard. And before, like 3 weeks ago, we only had measurements from Svalbard. We had one time lapse from Greenland and one time lapse from Antarctica, surprisingly enough. Somebody was on a cruise, I think, and shot some auroral beads, and there was a big geomagnetic storm. You usually don't see aurora from Antarctica, you have to be pretty far inland, but anyways, I posted about it on my Twitter account because I was at this ISSE meeting a few weeks ago, and we were talking about citizen science and aurora. We're trying to do this campaign to gather more observations of these FAEs. We just don't have enough. So I posted on Twitter, and this guy, Tom Warner, emails me a blog and also a whole time lapse in raw files of the sequence of aurora he shot from the Northwest Passage in northern Canada, showing beautiful fragmented auroral emissions. So it's the first observations we have from Canada. Also, you may not be able to see here, but they're correctly located, so there's really good GPS information and accurate timestamps, and that's extremely important. So this guy is not a scientist, he's just a sailor, and I think he's an electrical engineer by trade. But yeah, he just sent me these images, and it's like, this could be like multiple papers. I mean, it's just amazing. So anyways, just one example of, this science is literally happening now, right? We are getting these images and saying, holy crap, like this is not anything we've seen before. So this is probably the most recent discovery / area of research. I think there are only 2 papers total published on these FAEs. So yeah, this is some groundbreaking stuff here. And aurora chasers are at the forefront of it, which is really awesome. So now shifting gears a little bit, I've talked about aurora chasers collaborating with scientists, but scientists can also set up projects in which those collaborations are sort of facilitated through a platform. And these are all the projects in the quote unquote NASA citizen science portfolio. I just grabbed a slide from something else, but this is sort of the Helio Big Year umbrella here. And you can see Tritacular, Exoplanet Watch. There's all these different ones. HARP, you may know, that's more magnetospheric focus, but there's a lot of aurora ones. There's Citizen Kate, I know you're doing stuff with that. Ham Sci, great. So yeah, tons of citizen science projects, and they're making some great results. Just one that I want to highlight is Aurora Source. I was an intern for them back in 2020 when COVID happened. It's a great time. But Aurora Source is a great citizen science project and an example of an agile citizen science project. So what does that mean? Well, Aurora Source uses the agility of citizen scientists to their advantage. So the whole point of Aurora Source is that they're creating better estimates of where the aurora can be seen at any given point in time. So they crowdsource aurora reports from aurora chasers who then fill out a form on their website. It puts a little positive "I've seen aurora" marker on this map that also shows a model of the aurora. And this is great for validating. There's this model called the Ovation Prime model, which basically gives you a little donut of aurora, what the aurora oval should look like based on certain solar wind parameters. It also includes a view line, which tells people, or should tell people, where the furthest south or north, depending on the hemisphere, they can see aurora from. The problem is that this view line and the Ovation Prime model are not very well calibrated for geomagnetic storms because there's just not that much data that you can train the model on. So what tends to happen is people use this model and they say, oh, I only have a 2% chance of seeing aurora in Minnesota, when in reality there's aurora happening. They just are relying on this model that's not great, essentially. So that was sort of the whole premise on this, was there was this big geomagnetic storm all the way back in 2011, where aurora was seen as far south as Alabama. But the model was saying it's only seen in Minnesota or southern Canada. And obviously people missed out, right? Because they would look at the NOAA site and say, oh, it's a G5, but look at the oval, it's only here. The whole point is that aurora chasers can change sort of the way that we look at geomagnetic storms, and also that kind of goes into the space where there are R2O2R pipeline, as well as aurora chasers informing the models, and then communicating back and forth with the scientists how we need to improve things. There's also an ambassador network where aurora chasers who are very prominent in the community, so community leaders and the different aurora chasing groups online, like the Alberta Aurora Chasers, who helped discover Steve, are part of this group where we have monthly meetings with scientists who share what they're working on specific to auroras and research projects where aurora chasing and aurora chasers can help. So the ambassadors are sort of that link between the general public, sort of, you know, the people in the communities, and then the scientists, so sort of a translator between those different groups. There's also a bunch of educational content on the site as well. So as I was saying, you know, citizen science is just one way that we can educate the public. And you can also build communities through citizen science projects. You know, Aurora Source is basically the only reason why I'm here now. I met most of my friends through Aurora Source, and you know, that may sound cheesy, but really the Aurora chasing community is super tight knit and really strong. One of the first people I met through Aurora Source, his name's Andy, and I was talking to him back and forth, went up to Alaska in 2020, saw the Aurora for the first time from Alaska, and I was like, holy, this is way better than North Dakota. Like, this is, you know, you think you've seen it down here, you go to Alaska, it's completely different. It's mind blowing. So at that point I was like, okay, yep, Aurora science, I'm good to go. This is what I want to do. And then, you know, one thing led to another. Got more active on social media, you know, started taking more photos of the Aurora, got connected with more people. And yeah, literally everything was because of Aurora Source. So these citizen science projects, they produce great science results, but you're also forming communities. You're helping people connect with each other, people who have similar passions, people who are excited about science. I think that's underappreciated. You know, as a scientist, we're very focused on the data and on the results, and we kind of lose touch of the interpersonal ramifications that our research may have. And citizen science projects really do facilitate these communities just springing up all over the place. And you can use citizen science. So you can build a citizen science project that's probably the most relevant for people, unless you're an aurora chaser, in which case go outside, take photos. Although you're not seeing a whole lot of aurora from Durham, unless there's a big storm, and you might see a steep, who knows. But citizen science projects, I've already mentioned this before, you're connecting scientists with the public, and you know, the public effort can help you solve research questions. And it's not just aurora. So you might, you know, this could be applied to a lot of big data problems, whatever you're working on. And some tips, you know, this could be an entire talk in and of itself, but one of my favorite phrases just in life in general is simplicity is divinity. And if it seems hard for you, it's going to be infinitely harder for somebody who has no science background. So make it as simple as possible and as straightforward as you can. Also, another piece of advice I have is don't try and get everything right the first time. You're going to fail. Put something online. Build it in a project builder like Zooniverse if you don't have the resources to create your own platform. But just get something out there. You're going to have to beta test, be agile, and iterate. And what's nice about Zooniverse in particular is that actually they have people employed by Zooniverse to help you build your project. And also they'll send it to other Zooniverse team members to beta test it and then give you feedback as well. So there's Aurora Source on the top right. This is HARP. I believe this is Comet Hunters. This is Spectacular, and this is, I think, Sunspotter down here. Yep. Just some heliophysics projects there. And you can also leverage the Aurora chasing communities. You know, I'm a resource as well, so I have about 70 terabytes of photos on my hard drives that are just sitting there. I might have seen something, I still need to go through my photos. But there's a lot of data out there that just needs to be looked at. And, you know, you can directly reach out to photographers, aurora chasers. If you're, you know, doing aurora science, I know a lot of people here don't necessarily work with aurora, but if you're seeing something weird in the magnetosphere, some weird, you know, wave interactions, some plasma waves, you know, eventually those might work their way down and cause some emission in the ionosphere. You know, you could look for that in the data. But yeah, if you want to collaborate with people, just make sure that you have the reciprocity in mind and that you give people, you know, enough credit and you basically respect them is sort of the ultimate there. And we need more public engagement. This actually just happened. This was fun because I was putting together this talk and I could not focus this day because I was responding to conspiracy theorists on Twitter. And that can go down a rabbit hole, let me tell you. But who had issues with their phone last week in their service? AT&T and the AT&T users. Yeah, so a lot of people, so 50 million people lost cell coverage for almost an entire day last week. And there was one meteorologist at one station who said, oh, it's because of a solar flare, and boom, everybody ran with it. And it was a nightmare. I had a call with, I'm on the student planning committee for a space weather workshop, and there was a NOAA forecaster on the call, and he joined the call and he looked tired. And he said, yeah, I have not slept. So anyways, this just goes to show you that the public really don't know what space physics is or what space weather is. And, the aurora is beautiful, but we can do a lot more to highlight other areas of space physics, like the magnetosphere, like solar wind, like CME, solar flares. And we need to provide the public with factual and curated information. That can be done through citizen science projects where you have control over what information is out there and you can disseminate it in a way that's easily understood to people. And this needs to happen now because we're in the midst of solar max. This should have happened 10 years ago during the last solar max, but here we are. And if we don't do it, somebody else will. So here's somebody else. And actually, what's great is that she did issue a retraction. So this is kind of a cool story because this whole, event that took place last week, the whole community on Twitter and Instagram, Facebook really rallied. A lot of the space physics community who's present on there, basically in one voice said, no, it was on a solar flare. And now if you Google this, you cannot find a single article that attributes the blackout to a solar flare. Like they really nailed that down the first time that I've seen that. So that's really good. Now here's some challenges to citizen science that people have told me personally. So when I was writing a white paper for the decadal, it was on citizen science. And, you try and get co-signers to sort of, beef up what you're trying to say and, make it look better. And I sent the draft to a lot of, senior scientists at different institutions, and they said, oh, I don't believe in citizen science. It's not worth it. The data quality sucks and there's no use working with the public. I was like, whoa. Because before that, I thought, oh yeah, everybody loves citizen science. Because you're just kind of in this bubble, right? If you surround yourself with people who think the same as you, you're never going to know the outside things. So these were some of the common points that people brought up. Citizen science data are not reliable or have large errors. Sometimes some scientists, and this is sort of a personal thing, they just don't want to share credit. They don't trust the public, and they don't think that working with the public is a good use of their time. And then a lot of people were saying, AI is just replacing everything, right? We're all going to be taken over in 20 years by the singularity. So first point, citizen science data are not reliable or have large errors. Really, as I said before, the quality of citizen science data really depends on the project and how you design your project. If your project is good, the data will be good. If your interaction with the person who has the data is good, your data that you're going to get from them will also be good. And there's also some level of expectation of that too. You're not going to do spectral analysis on an iPhone photo. It's just not possible. But, right, if you have screws and nails on everything needs a hammer. So, just being realistic, but also realizing that not everything is due to the citizen scientists or the general public just being bad at, solving a remedial task. If it's a simple task, it should be no issue. And there's been so many results that have come from citizen science projects in space physics. So now this, this is kind of just yelling at people. Some scientists just don't want to share credit, but that's a form of reciprocity. So if you've done work with citizen scientists, that needs to happen. That's the bare minimum now. There's co-authorship on papers. Some scientists don't trust the public, but as I was saying before, people in the general public are not stupid. I think that's a big misconception, is that it's just the general public and they don't know anything. But in reality, these are people that might have PhDs in biology or be proficient in tons of trade skills, and those different perspectives can add to your science project. And then people think working with the public is a waste of time. Well, now it's actually not, because to get funding, you need to have broader impacts. And you actually need to specify how you're gonna create, for the better good. And I included citizen science on a lot of my applications, and that's helped me, but that's sort of the bare minimum. But then at the end of the day too, you are doing good for humanity and for society. That should be a motivator, you'd think. And then finally, the issue with AI. Maybe it'll be an issue in 20 years, but we're gonna have other issues too in 20 years. So right now, AI and citizen science are working together. And this is just one example. And the Etch a Cell project, is basically the idea of this. This is a Universe project, by the way, is you have these images of cells and you're asking citizen scientists to draw contours around the cells. And that gives you ideas of how big they are and whatever. I'm not super familiar with the project, but they ran an AI/ML, whatever, like you want to call it, model on. You can see that it doesn't do a great job, but then as they feed in the citizen science data, it gets better and better and better. So the citizen science data that are sort of cleaned data are informing the models is sort of the way that we're doing it now. Maybe that'll change in 15, 20, 25 years, but as for now, citizen scientists and AI are coexisting just fine. So just some concluding thoughts before I go to the fun show and tell part. You know, basically just summing up what I've said for the past 40 minutes is that citizen science makes heliophysics transdisciplinary, bringing the different expertise, domains to your project is really important. Citizen scientists are agile. You know, they have skills. Everyone has skills that they can bring to your project and help you find science results. And they really allow communities to flourish. They connect the general public to your science. If you're trying to get a message out to the general populace, one way to do that is through a citizen science project where you're training people who are already interested in your science to then go out and be messengers for your mission. And it's also just imperative that we educate people on space weather, and that needs to happen now. So now for the fun part, show and tell. So this is a Steve event that I captured on March 14th, 2021. This is when I was living in North Dakota. There's the Steve that came out there, and here's all of us being excited to go over it. So this was actually a funny, really funny night because, as I was saying, Steves usually happen after substorms. And you can see during substorm recovery, you get pulsating aurora, which are these flashes up to the north here. This is looking west. That's the picket fence right above. It looks kind of weird because the picket fence comes at odd angles, but you can see more of it, and that's the pulsating aurora. So it was funny because, you know, after the substorm, and this is common with aurora chasers, right? They say, okay, show's over, time to pack up. But you know, me being me, I was like, no, we're gonna stay. This is prime Steve hour. That's why I said this is prime Steve hour. Everyone was like, okay, whatever. Sure enough, Steve came out, and that's how I got the time lapse of Steve forming. Is that, you know, otherwise you're never gonna be pointing a camera to the west. But I knew, you know, maybe Steve was gonna come out, and sure enough, it did. Here's a weird one. This, I think, is maybe a ragda, not really sure. Ragda is kind of a weird one. So this was a weird, so the main aurora is off to the right here. This is again looking west. There was this weird, I like to call it a stable auroral green arc, maybe a SAG arc. Again, you know, people with their names. There seems to be, there's 1,000 names like the Aurora Zoo now. Anyways, it faded out into this SAR arc, which I just thought was weird. I don't think people have been paying enough attention to specifically this night, because there were data reported by maybe 20 different citizen scientists, 20 different aurora chasers all across the area, not only in North Dakota, but Minnesota, Manitoba. And what's really cool, I didn't mention this, but when you have multiple images taken from multiple locations, you can just use basic triangulation to figure out the heights of different auroral features and the spatial sort of structure of aurora, which is really, really valuable to understanding of how the emission is happening, what processes are driving that. So this is just one example of, I saw something weird, so I photographed it. And that's a common theme with aurora chasers is we're out in the field for so long, we've been doing this for so long that we start noticing things. And that's how you get the cool science is, you know, all the cool science comes from really rare and weird events. This is really what changed my life here. I was up for the LAMP sounding rocket mission back in 2022. This was actually right as I was finishing my bachelor's degree, and this is the best aurora that I ever saw. Still probably like a top 5 display. This is a real-time video looking straight up, and this is on the right, a still image. And that's the Fort Yukon long-range radar site over there where I was staying. It's basically like this Air Force outpost. And I was there for 3 weeks, and we actually launched during this night. So right after this giant substorm, the goal was to launch in the pulsating aurora. We got some amazing pulsating aurora. So yeah, the aurora can actually move that fast. And I started calling this one the Aurora cinnamon roll, because you can see it looks like a cinnamon roll. So I want to give credit to myself as being the namer of the Aurora cinnamon roll. So if you ever see that, I was looking and nobody else was calling it that before. So now it's all over the place. I don't know. I'm holding credit on that one. So this was just one of the adventures that I had. 2022, I was doing a lot of road chasing actually. Yeah, grad school didn't have no time. So as we can all relate. So this was 1 week of aurora chasing in Churchill, Manitoba. If you don't know where Churchill is, it's right on the shores of the Hudson Bay in Manitoba. Manitoba's huge. So you know, it goes all the way from Minnesota, North Dakota, all the way up nearly 500 miles to the Hudson Bay. And the only way you can get to Churchill is by train or plane. There's no roads. So I took a train 16 hours from Thompson And, you know, there's lots of polar bears. We didn't see any on this one in March, but, these are all people who I met through Aurora Source as well. Literally every single person here is an ambassador for Aurora Source, which is kind of cool. And we saw some amazing aurora there for about 8 days. And this is an old abandoned radar facility up there in Churchill. There actually is a spaceport that they were trying to build in Churchill. So there's a bunch of like abandoned rocket launchers. They used to launch sounding rockets out of there too. It's really, really cool. Here's some more. This was a nice substorm. So, you know, up at these high latitudes, you don't really worry about KP. So I think this was like a KP1. This was like a KP0, and this was like a KP6, right? They all look about the same. So that's just the thing, is when you're up in Alaska or Churchill, you don't look at KP at all. You never really should look at KP, honestly, but definitely on the high latitudes, for aurora chasing purposes, that is. I went back to Churchill in September of the same year, and that's more around polar bear season, so saw 4 polar bears. This one was the scariest because this was on our way back from aurora chasing, and when you're driving in Churchill and you're out aurora chasing, especially during polar bear season, usually you have one person sticking their head out the sunroof with a big spotlight scanning the trees as you drive and make sure you don't see any polar bears. And the way that you can see polar bears or any other animals is by the glowing of their eyes. And actually it was fun because we had a drone, so we would send that up too and scout around, because these polar bears, I mean, they'll sneak up on you and they don't, I mean, they're pretty aggressive. Usually they're mostly afraid of you. They're more curious, but you just don't want to run into one under any circumstance. But yeah, we saw 4 polar bears. This was the closest encounter was we almost actually hit one as we were driving. So we rounded this corner. It was actually called Dead Man's Corner, which is ironic because there's a polar bear right there. But by the time I whipped out my phone, he was already scampering away. But yeah, and then you can see the Hudson Bay in the background, and then yeah, here's just replay that again. I mean, he was literally from the car to the owl, basically, is how close he was, and then he just ran away. So we drove up, but yeah, they're beautiful, but they're also deadly. So here's the aurora that we saw. Obviously, these are just a few shots. Really, really good stuff from this trip. It's one of my favorite shots down at the bottom right, another cinnamon roll. There's another, maybe it's more of a cinnamon bun, this one up here. So yeah, really, really fun. And if you ever have a chance to go to Churchill, you should definitely take it. I went for 3 weeks this time, so I was there for a while. This was during a gap semester, almost a gap year basically, but so I just aurora chased basically for the entire time. So I flew to Winnipeg and then took a train for 42 hours. Was how long that one was. That was a journey up to Churchill, but it's just beautiful. Here's something a little closer to home in Fairbanks. This was a really, really nice substorm that we had March 23rd of last year. Really, really good event. Maybe you have looked at that one, but it was a KP7 event, and Fairbanks was like perfectly positioned. You know, a lot of people think, oh, you're so far north, those big KPs, you're not going to get anything, so you're almost too far south. Well, that's kind of true. You know, with the expansion phase of substorms, the aurora races poleward, right? So we actually get the substorms as they come washing over us. Usually they initiate somewhere over Anchorage or Juneau, but we get the aurora then coming right to the north. And there were some really, really gorgeous purples as well, because this happened like right after sunset. So these blue and purple colors are actually not, you know, no, actually the purple is not normal. The blue is caused by photoionization of upper level nitrogen, so by the sun. So if you have a really strong aurora right after sunset, you'll get sunlight hitting the tops of the aurora. It creates blue, and then the purple is due to a mixing of the blue and the red. So we had some really, really nice blues this night. This is facing west as well, so just really, really pretty. And I was out leading a workshop. This is a week-long workshop, and we had aurora every single night. And this is still the best aurora I've ever seen. And we had one person, it was really funny. She was flying all the way from India just for one night, and she saw this and then flew back the next day. I was like, you need to buy a lottery ticket. I have never seen anybody get that lucky. Coming to Fairbanks for one night automatically red flag, right? It's gonna be fun, right? Guaranteed. But no, she saw this. I was like, yeah, you need a lottery ticket because this is the best aurora I've ever seen. So yeah, and this was just one of like 4 substorms at night. During big geomagnetic storms, I mean, you can just get substorm after substorm, and it's just nonstop.
What's like the time scale of this video?
Yeah, so I don't know exactly how long
Approximately.
so the full time lapse that I have is much, much longer than this, and that was like an 8-hour time lapse. But I think just like from when I started the time lapse to right here, that's probably like 10 minutes maybe.
Whoa.
But yeah, like from one edge of the screen to the other edge, that maybe only took 2 minutes. So it was really racing. And then here's the most recent example I have. I have a bunch of other photos too, I just haven't gone through them. You know, when you have like 20 terabytes of photos, your computer just takes weeks to go through like one time lapse. So this was a KP8 event, and actually this is at the end of April. So my friends and I are kind of crazy. It was at a point in the summer where we don't get full darkness in Fairbanks, so we drove 3 hours south so that we can get some darkness. And we saw some really, really nice aurora, some really nice blue aurora too, because even down here, there was not full night. You only had astronomical twilight. So I think April 14th is the last night of official night for Fairbanks. But as you go further south, that becomes later and later in the year. So yeah, really nice blues here caused by the sunlight. And yeah, that's all I have. Thank you so much for your attention. Yeah.
Awesome images and
You're welcome.
as well as discussion. Any questions for awfully good speaker? Wait, we are brain slip.
Couple questions. But if it's like when it's like super intense,
Mhm.
can you like hear nothing?
Ooh, that's actually a great question. So that, I get that all the time. I've never heard the aurora, but I know people who swear that they've heard it. Especially a lot of indigenous people.
Oh.
Yeah, people who have lived there for decades in Fairbanks and in Churchill. They're like, oh yeah, I've heard the aurora. I've never heard it. And there's no scientific proof that it's a sound that you can actually hear.
I'm
There's
imagining it sounds like G sharp.
people actually describe it as sizzling bacon.
Whoa.
Yeah,
that's cool.
like crackling, like you know how you have like Rice Krispies?
Oh,
Like that.
what is the candy thing that you put on your tongue?
Pop rocks.
Yeah.
Yeah, like those.
Well, I know one thing that I've come across when talking to a lot of different like researchers is using very different names for the same thing.
Yeah.
How do you kind of deal with that? Like if I wanna look for a specific kind of aurora and you have that giant data set and amount of pictures, how
Right.
do you know what to kind of look for?
Yeah, that's an issue right now, I think, because the field is just so young, like the
Yeah.
specific subfield of auroral physics is so young. There's really no standardization of the features. I think that there's two things to that though, is that, you know, you don't wanna tell people, oh no, that's not this. Like, people are excited, like they wanna name something, they want some ownership and just feel good about what they discovered. So it's fine, I think, if there's lots of names, but there are citizen science platforms. One of them is called Skywarden, where people can tag their photos with the different phenomena that they're seeing. So people will upload a photo of the aurora and they'll say, oh, hashtag Steve, hashtag Ragda, hashtag pulsating, hashtag dunes. And then you can go through in that database and you can just filter out every single thing. So you can see all the different submissions and all the different names. And then there's people who actually manage that too. So they'll group. So if someone says, oh, this is like I called one time I called this red arc sandwiched between two green arcs and aurora sandwich, right? And like, nobody's gonna know what that is, but somebody who works for Skywarden would say, oh, that's a Ragda, and then take it with the right thing. So there's efforts being made, but it still kind of is an issue.
Well, thanks.
When you get
Yes.
the big pillars moving across the sky, like east, west, west, east, what determines that direction?
Okay, so I'm not an expert on that, but there is like global convection in the upper atmosphere that sort of dictates what direction, you know, things move based on what time of the night you're in. So before what's called magnetic midnight, things typically go from east to west, and then there's magnetic midnight where then that reverses from west to east.
That was my guess, I just wanted.
Yeah, so part of a substorm, if you're not right over the substorm initiation point, which is when you see the aurora sort of explode right overhead, is you'll see a surge coming from the east or the west, depending on if you're really early in the night or really late in the night. So in Fairbanks, if we have a substorm, that happened, let's say over central Canada at like 10 PM local time in Fairbanks, we'll see a big sort of bulge of aurora coming from the east and then moving towards the west. And then similarly, if it's like 4 or 5 AM, it comes from the west and moves towards the east.
Thank you.
Got a question about reciprocity aspect of
Yes.
citizen science. So obviously that's very important.
Yeah.
But I can see as a scientist, it would be super convenient to just like build an instrument, put it in a black box with a button on it and say, put this in your backyard and press the button once every 3 hours. And we'll include you in publication. You don't need to know anything. Which like, obviously that's not good. So
Yeah.
where do you, like, what is your opinion on where that line should be between having the citizen scientists be very involved and like getting that reward out of it, of the knowledge they gain, versus foolproofing and streamlining method?
Yeah, I think like everything, it depends, right? I think it's a case by case basis. So there are times when you just hand somebody a box and tell them, just put this in your backyard, bury it 6 feet underground. And here's what it is, but you don't need to really know anything more than that. And for some people, they're okay with that. I think, but I also think providing as much information and then sort of seeing the reactions is important too. Like some people might not, they might be nervous to talk to scientists, so they won't say anything. I think it just matters case by case. I mean, I think more information is always better though. So having a good instruction, like an instruction manual for your instrument, that's important. But yeah, case by case.
Is there anything that like a large, sort of like, a lot of the groups and everything you're describing, is there anything like a larger organization, like something like AGU could do? That could standardize interactions
Yeah.
between scientists and the public? Where you're
Yeah.
saying like, if you're gonna, because it's just the Wild West, where it's
Right.
up to the scientists to sort of set the boundaries.
Mm-hmm.
Is there any sort of move towards like a large organization?
Yeah.
Getting involved?
So one thing, so I'm on this ISI team, it's called Arctics, and one thing we're doing is writing a handbook for exactly that. It's interactions between citizen scientists and scientists, and there's a section that's just labeled for scientists. There's a section that's labeled for citizen scientists, and it outlines exactly what you were saying. Sort of the leading practices or standards, as of now, because everything changes over time, but sort of how people should behave themselves and act when they're collaborating. But right now, in general, it's pretty disjointed. There's a lot of really good efforts being made in different areas, but it's sort of parallelized in a way that's not efficient, so.
Is there stuff that like journals could do also in terms of
Yeah.
like, if you're using citizen science, then you need to.
I want to say that there's some initiatives for that. There are journals in citizen science, like there's a citizen science theory and practice journal, which is just focused on citizen science, but I don't know. I mean, it seems like journals do reward citizen science publications in a way, which is good, but I'm not sure exactly how that happens.
So, I was also thinking like some of the best ways to, when you were talking about like people seeing different things and labeling
Yeah.
different. One of like the best ways that I found like to stay on the same page with people is conferences.
Right.
And I can see how something like AGU, for example, would be obviously really intimidating for somebody and also
Right.
cost prohibitive.
Right, oh yeah, that's another issue too, is that citizen scientists can't afford to go to conferences and participate. And big issue now, so during COVID, COVID was almost a blessing in disguise in that aspect because everything was virtual. So now you have people who don't have funding usually joining, sitting at the table with all these scientists, but now everything's moving back to in person. And like, the Space Weather Workshop, for example, is completely in person now. Like they're totally getting rid of the virtual component, which is good in some ways, good in bad ways, or bad in some other ways. But yeah, there's a lot of push and it seems like people are finally waking up to the fact that there needs to be alternative funding for people who have something to contribute but just can't make it. So I think there's hope.
Well, can I ask a question?
Yeah.
Okay, so for like a night like this
Yeah.
to observe, this thing, what do you bring, like, can you walk me through like the night?
Yeah.
Get out of the car, like, are people aggressive if you use flashlights, you have to have like red lens?
Yeah, no, you're right, yeah, people, me, I don't like when people use white lights.
Right.
So I personally try and like not go to the touristy areas, so whenever somebody tells me, oh, where should I go to see Aurora? I was in a safe place. And then I'll like drive past and there's just like a parking lot of people. Because, I mean, people just don't know the etiquette, you know, they'll pull into a parking lot and leave their lights on and leave their car running, and really you should, you know, try and pull in with your lights off, which is kind of dangerous, but I do that sometimes. We'll just be driving in the dark, so I'm not messing up people's shots, but, you know, and then sit there with your lights off. That's pretty basic, but yeah, people don't even know how to do that. And then, yeah, people use literally with their iPhones or, you know, phones out, taking photos of the aurora with their flash on. And it's like, what's going on there? Like, what's happening?
Yeah, that might just be an accident.
No, you know, you would think that, and then you see it every 2 or 3 minutes.
First time
It's
it's an
like-
accident, second time.
Yeah, first time it's an accident, the next 20 times are not. But yeah, no, usually what I'll do is I'll check the data throughout the day and see like what space weather's doing. So, you know, I have all the data sources bookmarked, like real-time solar wind, GOES Mag, AE index, Ovation Prime, because, you know, even though I was talking bad about Ovation, it is good just for seeing, okay, what is the solar wind really doing to the aurora? Because it does, you know, it's the best fit, magnetospheric coupling parameter or whatever, you know, that exists. So it is useful, but, yeah, you should just check the data, and then around 6, 7 PM or whenever it starts getting dark, I'll, you know, if the data looks really good, I'll scout out a spot. Before I would really go out far, like I would drive 2 or 3 hours sometimes, just to get a good shot, you know, try and get it away from the city as much as possible, but now with school and in classes, yeah, it's usually in the backyard or at a friend's house, because I need to be up at 9 AM the next day, so, yeah, I bring out all my cameras. I have 4 cameras, so I usually set those up in time lapses, and then, you know, even if the aurora's not doing anything, it's kind of cool to get a time lapse of the whole substorm cycle, like from the growth to expansion to recovery. I really like seeing that. So I usually just set everything up and then just wait. And if the aurora looks like it's not gonna do anything for the next couple hours, you can usually tell with the data, and I'll take stuff down and pack up and go home. But you know, if it looks like there's gonna be a chance, I'll try and stay out as long as possible. And there was one night, actually just on Saturday, was it Friday night? Yeah, just this last Friday, everything looked really, really good. But I had to be up early the next day, and it was like 2 AM, and I was just trying to fight sleep, and I eventually caved. I went to sleep 2:49 AM, boom, the aurora just went off. It's like, damn, I really missed that one. So it really pays to be a night owl in Alaska, because our magnetic midnight's also later too. It's like at 1:30. So yeah, I mean, every night's different, but I'm checking it all the time, so.